This is Umozo3. It's the weekend here. It's a Sunday, so hopefully you're doing well. But today we're going to be talking about lesson 32, which is in regard to something called Itertools. Okay, so about 16 lessons ago, we talked about modules, and we said that we can basically import functions and functionality into our program that someone has already figured out how to write. And maybe that can expand the functionality of our code without us needing to figure out how to implement a task that someone has already figured out for us, and then we can just use. But what we're going to do is we're going to remind ourselves of what recursion is, okay? And we said in the previous video that recursion is a technique where basically a function calls on itself. And so the question is, that's kind of confusing, because how could a function be defined by the function itself? And it's a little bit confusing, but what happens is, as you call the function over and over again, you reduce down to a simpler base case, okay? And so here what the example is, what one of the third example that we did, and maybe we'll see one more today, is we say print v of k and v, okay? And so what this does is going to accept an integer k and some item to print v, okay? And we're gonna be pretty liberal about the type of data, the data type that v is. It really could just be anything that could be printed. So anything from a tuple of booleans to a dictionary of integers, right? It doesn't really matter, but, or dictionary where the values are integers. But anyway, so if k equals 1, we're just going to go ahead and print v, whatever the symbol v is, right? So, oh, you just want to print it one time, you print it. This part is a little bit trickier. So it says, otherwise, if k is greater than 1, I need you to go ahead and print, one version, one copy of v, but then go ahead and just apply this algorithm for the next lower value of k. And so this code is going to run a number of times. Odds are that when we first, make a call to this function, k is not going to be equal to 1. It's going to be greater than 1, right? And so we're presuming a positive integer, right? And if we wanted to really mandate, that the, where am I here? So if I really wanted to mandate that the user entered at least k equals 1, we could say else. And then we could say something like we could raise a type of exception. So we could raise a value exception or something like that. And then we could say something like k cannot be less than 1 or something like that. I think it's called a value exception. It might be called something like that. Let's call value error. So I think we've talked about exceptions in lesson 17 and 18. So we're reviewing fundamentals, and you can see that this curriculum is pretty cumulative. So it makes sense to do the lessons in order. But you could go ahead and raise the value error if you were, passing in a negative value, right? But here, when we ran print v of 4 with my list, it was able to print my list 4 times. So hopefully that makes sense to how this algorithm works. And then we also talked about the Fibonacci sequence and the factorial, okay? And we could have one more. What if we want to multiply 2 numbers together? So what if we want to say define multiply them of x and y, okay? And then what we could do is we could say something like, if y is equal to 1, then we could just say return x, otherwise, if y is bigger than 1, what you would do is you would say return x plus multiply them of x and y minus 1. So y is the number of times that you are going to add x to itself, okay? And then that should not be a problem except for the fact that we spelled it wrong. And then we can go ahead and say print multiply them. And this would work. X can be negative, but y cannot be negative, okay? Because y is the number of times that you're multiplying x. So then if we go ahead and say -3 and 10, again, this is going to be Java, or this is Java syntax, not Python. So sorry, I need to say elif. I've been writing a lot of Java code recently, so you have to be careful when you're practicing or mastering multiple languages at the same time. Sometimes it's nice to actually just know one language. But anyway, if you go ahead and run that, we get the -30. So let's move on. We're going to talk about Itertools. So Itertools is a great module for working with iterables, right? We've already seen a couple of examples of Itertools. You might remember that we've already seen a couple of examples of modules, excuse me. We've already talked about the math module, remember? And it had functions like cosine and square root in it and things like that. And so we can go ahead and pull up the Itertools module, okay? And so if you don't remember how to get here, what I would recommend doing is just going to blackwell.com, and then you could go Python Itertools, okay? And so it's pretty straightforward. You're just gonna be Googling a package, and it's called Itertools. You need to spell it right, and presumably by the nature of the word, Itertools. So it's tools for working with iterables, okay? They didn't just pull this word out of their ass. They're trying to come up with an intuitive intuitive description of what it is that the functions within this module are intended to do. What are they intended to help out with, and why would we import this module? And it has to do with, this module implements a number of iterator building blocks inspired by constructs from APL, Haskell, and SML. So anyway, it just has a lot of cool functions here. So this would allow you to basically go through a list over and over again. So what if you just wanted to iterate through a list multiple times? So we're going to have functionality for that. What if you wanted to keep a running total of elements in a list? Okay, so if you have an 8, 2, 3, 7, it would be able to add them up along the way. You'd get the 8 and then the 10 and then the 13 and the 20. Okay, so keep a running total. Okay, and the product and permutations, these are sort of mathematical things. Hopefully you're familiar with some of these words from a more mathematical or less programming oriented context, but now we're going to see them in the programming world. We said that in order to use a module, we need to go ahead and import it. So what we're going to do is we're going to scroll all the way up to the top of the code, and you can see something here. So essentially what we're going to do is we're going to import 8 functions from Itertools. Okay, there's 2 ways to do this. You can either just import the whole package. So one of the things we said is that you could either just say for Itertools, and then when you want to use a function from Itertools, you would need to say itertools.count of x or itertools.cycle of x, assuming that the count and cycle functions accept one input. But what we're going to do is and then we could go ahead and say something. We could have as's in here, right? So we could say count as C, right? And cycle as D, okay? And then we could go ahead and refer to those things. So we could say, basically, we could say print, we could say this would not work in code really, because it actually returns an infinite result. But you could say list of count of 3, and it wouldn't know what you're talking about, right? And then if you said itertools.count of 3, it would still have a problem with that. If you're going to import it as C, a particular function, you just say C of 3, okay? And it would know what that means. So you need to import these 8 functions. Hopefully I'm not blocking them up here, but you're going to have count, cycle, repeat, takewhile, chain, accumulate, product, and then this last one is permutations. So I think that's getting cut off there at the end, but hopefully you can see it now. Just the word permutations, okay? And these are all the common spellings. Just make sure you spell them right, okay? So don't have any typos or anything. But what we're going to do is we're going to investigate these 8 functions, okay? So I'm going to scroll down. I already have descriptions for all of them. We're going to talk about what they do and how to use them. There's 8 of them in total. I think they're pretty straightforward. I think we only need 1 or 2 minutes for each of them. Itertools module is great for working with iterables if we're talking about lists, sets, tuples, dictionaries, or generators. So we said, remember, if we have something like a range of 5, or map of function iterable, or filter of predicate iterable, right? Those don't return anything, but they yield values that can be used in a for loop. We've already talked about that. So what count of x does is it's a generator that yields all values starting at x, going x plus 1, x plus 2, x plus 3 up to infinity. And that can actually be sort of helpful, right? So remember, range of x starts at 0 and yields everything up to x minus 1. Count of x is kind of the opposite. Count of x starts at x and just goes uphill from there. So what we're going to do is we're going to see a little example. What we're going to do is we're going to create a function called print x to 20, and it's going to accept an x, and it's going to be on your own to produce Java docs here. So here, there's not going to be any return type in your Java docs, but there should be a short description of what it is that this function does and what type of input x is. So you need to go ahead and do that on your own time. But what we're going to do is we're going to say for s in count of x, okay? And the problem here is that I imported count as C, so I'm actually just going to use the standard function names. We're going to call them count, cycle, repeat, and so on, just to make things, less ambiguous here. So what we're going to do now, C of 3 doesn't work, right? So now let's go ahead and delete that. And so what we're going to say is for s in count of x, if s is greater than 20, break, okay? Or otherwise, right, if this Boolean was not true, it would just come down here, right? But if it breaks, then it doesn't come down here. And that's why we said that you could do this with an else statement, but it wouldn't make a difference. So you say if s gets bigger than 20, you're going to break out, okay? But for print x to 20 of 10, it's going to say for s in count of 10. So it's just going to print, 10, 11, 12, 13, none of those are bigger than 20. So you're going to print all the values of s, but then when s gets bigger than 20, you're going to break off, because otherwise you'd be trailing up to infinity. So with count, you're probably going to be talking about using a break, okay? And so that's why we get 10 up through 20. So hopefully that's clear to you. we're going to talk about the cycle. Okay, so what cycle of X does is it accepts a list and iterates through it over and over again indefinitely. Okay, so if you said print list of cycle of, and then a list 2 and 3, what it would do is it would just basically, I mean, I guess you couldn't really print a list representation of that because cycle and count are infinite generators. Okay, these are infinite generators. So you want to be careful when you do something like convert it to a list. In fact, for these types of generators, it actually makes more sense to just use it with a for loop, to just say for S and count of 10, rather than trying to, you know, like use count of 10 as an object in and of itself. So anyway, hopefully that's sense, but cycle through. So what we're going to do is we're going to say S equals 0. We're going to keep up with an index position again. For R in cycle of my list, okay, so it's calling the generator, which we imported from the Itertools module. Okay, so if it says if S is equal to T, whatever this number is coming up here, you're going to break out. Okay, so that kind of seems like T is going to be some limiting condition here. Okay, and otherwise you're going to print R and you're going to increment S. Okay, you have to keep up with S because otherwise this print thing is just going to go indefinitely. So that's why you absolutely need this Boolean, because, you know, this is sort of like saying while true. You know, it's just going to keep iterating through the elements over and over again. So hopefully that makes sense to you. But now what we can do is we can uncomment this line of code and then we'll comment out the count example that we just saw. So then if we go ahead and run it, and we have an indentation error on, let's see. So then we have, maybe we have an extra space there or something. Maybe it didn't like that we had an extra space at the beginning of that line. So then we can go ahead and then we get the, you know, we get 4, 5, 8, 2, 4, 5, 8, 2, 4, 5. So it printed, you know, 10 elements like within the list. And if it has to go back around, then it will do that. Okay. What we have is we have a repeat generator. So repeat of X accepts an item and yields the item indefinitely. It's kind of like cycle of X, but instead of talking about going through a list or a tuple or an iterable, it's just one element, okay? And you just yield the element over and over again. So if you say repeat me of X and T, you would say S equals 0. Again, you keep up with S. For R in repeat of T, you know, it's a generator, okay? If S is greater than or equal to T, again, we're going to break out, but otherwise I just want you to print the element and then increment S so that eventually this Boolean, which allows us to break out of the repeat generator, will be true. Okay, so now what we're going to go ahead and do is run it. And obviously I would probably want to go ahead and uncomment these lines of code. So we're just going to see what happens. And I'm going to try printing repeat of 5, 2, because we need to remind ourselves that this is a generator and it doesn't print anything. So it just says repeat of 5, 2. But then if you go ahead and say repeat me with this tuple and this integer input, then you get that tuple 3 times. So hopefully that's clear to you. But we're going to go ahead and comment that out and look at the next one. Okay, so we're moving along here. So take while of xy. It's a generator that accepts a predicate x and yields the elements from iterable y while x is true. Okay, so it's basically going to yield the elements of the list, but only until the Boolean is true. So once you get to an element where the Boolean, remember the predicate, is no longer true, it's kind of like a while loop. It's going to snap out and it's going to stop yielding values from the list. Okay, and if the Boolean is always true, it's going to yield the entire list. Okay, so remember a predicate is just a Boolean and lambda syntax that applies to an arbitrary element within a list. So let's go see a quick example. We need to keep moving here. So then if we go ahead and do, you know, stop at negative, right? So if you say for R in take while of, and then this is a syntax for a predicate, right? It's just a lambda Boolean basically that applies arbitrarily to elements A within a tuple, my tuple, okay? And you're just gonna say print of R, and then you can see a negative number in here. So hopefully we would just be printing 3, 0, 1 on 3 different lines, but we would not be printing the -1. Okay, so then if we go ahead and comment out the previous example, then if we uncomment the current example, hopefully this is clear to you. So then if we go ahead and run it, then indeed, oops, we need to uncomment it, right? So then if we go ahead and run it, and I guess we're still repeating the stuff above, but you get 3, 0, 1. So hopefully that makes sense to you. So now let's comment that out and now comment the previous example. And now let's look at the chain, okay? So what chain of XY does, and it's going to say it could accept multiple inputs. It accept 22 if you want, but it's going to accept the multiple iterables and just yield through the values in each one iterable at a time. Okay, so it's just like iterating through, but you're going to iterate through X. and then you're going to print the values in y, and then you're going to print the values of z. And whether you pass in one input, that's fine, or you could pass in, I think you can just pass in one input, but usually with chain, we're talking about chaining together at least two iterables, okay? So you'd probably have a comma in there, be passing in at least two things, but you could pass in 102 if you want. But it would just say for u in chain of A, B, C, print u, okay? So we can basically see how this generator works. We're gonna say my chain of, and we're gonna pass in a tuple, a set, and then a list, and so we can go ahead and run it. And then indeed you get, what do you go ahead and get here? So then, you know, we had the 4, 5, 8, 2, 4, 5, 8, 2, 4, 5. This was from a previous example. Sorry, this is a little confusing. I'm just gonna comment this out for now. Sorry, so let's go ahead and run it. So then we get, you know, we get the 3A false, okay? We get the 3A false, 0, 1, 5, 9.0, okay? And the negative 30 is from when we did the, that was from the recursive example at the beginning. That was from this multiply them thing that we were talking about at the beginning. But now let's talk about the next one. So now we can talk about accumulative x, okay? So accumulative x needs to accept some kind of numerical iterable. It can only have numbers in it. We're only talking about instant floats. Because what it's going to do is it's going to accept an iterable x and yield a running total of the values in x. So what we're going to do is we're going to say accumulate me of y. It's a function. And what we're going to do is we're going to reference the generator within the function. So we're just going to say for z and accumulate of y, print z. Okay, so now if we go ahead and run it, we can see what would happen here. So now let's go ahead and comment out that line of code. And we're going to comment out the negative 30 because it was a little distracting a minute ago. And then now let's take a look at what we get here. So now we have the 4. And then we have the 5.1 plus, because 4 plus 1.1 is 5.1. And then you have minus 10, right? It's adding on negative 10 to get back down to negative 4.9. And then it adds on to 3. And you can see a little bit of a rounding issue here. We've seen this a few times so far. But basically, this will be treated as negative 1.9, okay? And one of the things we talked about is round, okay? So I think we talked about round of x. I think that's from the math module, or it's some kind of a numeric function, but you could figure out how to make this cleaner by calling round, okay? Round of 3, a round of that last value. So anyway, hopefully that makes sense to you. But anyway, it's just a rounding error. But anyway, that's a running total, okay? What about product of xy? We have 2 more to talk about. So product of xy accepts 2 iterables and yields the collection of all tuples where the element in the first index position of the tuple is from x, and the element in the second position of the tuple is from y. So basically, we're thinking about combinations. We're thinking about Cartesian products. What are all the ways that you could get one element from the first list and another element from the second list, right? If you had like a Cartesian product of all the cities in California with all the cities in Florida, right? You could have San Francisco, Miami, but also San Francisco, Tampa, San Francisco, Tallahassee, right? And then you'd also have, you know, San Diego, Tampa, San Diego, Miami, San Diego, Tallahassee. So those are combinations, right? And so then if we go ahead and see an example of that, so now what we're going to do is go down to my product. Okay, it's a function that we made and accepts 2 inputs. You can call them whatever the hell you want, as long as, you know, those names are kept consistent. So what you're going to do is you're just going to call the generator that we imported from the Itertools module. We're going to say for P and product of cookie and brownie. Okay, so the Python knows what product means because it was imported. So what we do is we say print P, okay? And so we're just going to figure out what would be yielded by this product generator if it applies to this tuple in this list. So now what we're going to do is we're going to uncomment line 99, comment back out line 91 from the previous example. And then if we go ahead and run it. So let's take a look at this, right? So now we have, and remember, these are tuples. They're all just going to be tuples. And so it seems like Python kind of, sometimes it seems like Python likes to sort of prefers to return things as tuples, right? But what you have is 5, 1, 5, 2, 5, 6, 5, 5, okay? And then 4, 2, 4, 1, 4, 2, 4, 6, 4, 5. So hopefully you can follow along with that process and figure out that if your first iterable has n elements and your second one has k, then you should have n times k permutations. Hopefully that makes sense to you. And then finally, we're a minute and a half. So permutations of x is another generator, 8 generators in this video, that accepts an iterable x and yields all permutations or orderings of elements, okay? If you have duplicate elements, those elements are considered distinct from one another, okay? So if you have a 1 and a 1, right, then this 1 and 1 is different from this 1 and 1, okay? Because you know, so there would basically, you know, you could have duplicates here. So now let's go ahead and take a look at that. So what I'm going to do is comment back out line 99 and uncomment line 107. So we have a function very simple here to find my permutation of snake. For frog in permutations of snake, we would just say print of frog. Okay, so then if we went ahead and operated my permutation on this iterable, hopefully we would be able to see all the orderings of these elements. Okay, so you'd have 5, 2 snow, but you'd also have 5 snow 2. Okay, you'd have 2, 5 snow, but you'd also have 2 snow 5. You'd have snow 5, 2, but you'd also have snow 2, 5. So now we can go ahead and run it. And for 3 elements, we expect 3 factorial combinations. We talked about factorial in the previous video and implemented it, but that's true. Okay, so if you're doing products with 2 iterables, it'll be, you know, this many elements times this many. And then if you're doing a permutation, it'll be the factorial. So hopefully that's interesting, and those are some powerful tools to use. From UMOS03, thanks for watching, and please subscribe.